Hi, everybody. This is the rope problem in the written assignment for perimeter and area. So let's just go ahead and take a look here. The question is asking um, how long is the rope, right? So if you actually think about what actually is consider that rope, well, that rope, let's say we start here, that rope goes here, right? And then it's this part, this much of the circle, and then it has this straight line, and then it has this part of the circle, and then this straight line, and then this part of the circle, right? So these parts of the circles are of the same size, it seems. So as long as I could find one part of the circle, then or just one of these straight length here, then I could find the actual length of the rope, right? So I'm going to go ahead and read the instruction here. It said the radius is perpendicular to the tangent line at the point of tangency. Okay, what does that mean? Well, here is the point of tangency. That's this guy right here, right? And so suppose you have this center right here. The radius is here, and it said the radius is perpendicular to the point of tangency, like where that straight line touches the circle. The same thing can happen here. So that would be right here, right, to that point of tangency is also perpendicular. And then if you connect this part right here, you will see that that part would be the diameter of the circle, because this is one radius, that's another radius, right? And the radius and the diameter of the circle is 20 inches. So that dotted line is the same as that straight length there. And so that would be 20 inches. And the reason why it's the same is because if this is going to be a right angle, this is going to be a right angle, and then this length is the same as this length, then that's going to make this four-sided shape a rectangle, right? So a rectangle, then so that means that this length on the outside here, the straight part of this right here, is going to be the same as the diameter of the circle, which is 20 inches. So that would be 20 inches here, and then 20 inches here, right? So so far you already have 60 inches. And then the question now is, how much is this part of the circle? Let's think about that for a second. And I am going to zoom in so that you can see a little bit better. So there we go, right? So we have, let's take a look here. So this is going to be 90 degrees, because that we said that it has to be a rectangle. Since this angle is a right angle, this length is equal to this length, because they're both the radius of the circle, and this is a right angle. Therefore this part right here is going to have to be the same as this part right here, which would give us 20 inches. But the most important part is that it has to be a rectangle. So this right here is going to be 90 degrees as well, this angle right here. Okay, now I'm going to go ahead and add the center right here as well, right? And I'm going to go ahead and connect these centers of the circle. And you will see that that triangle in the middle is an equilateral triangle, because it has 3 equal sides. That's 2 radius, or 2 radii, and this is also 2 radii, right? So if that's an equilateral triangle, this part right here, we can say that that angle right there is 60 degrees. Okay, so far we already cut off 150 degree out of a full rotation of 360 degrees, right? So let's go ahead and, oopsie, what just happened? Let's go ahead and take a look at this right here. Okay, so if you think about this part down to here, this is a right angle. The radius is perpendicular to the line right there as the point of tangency. So this part right here is a right angle also. So this is 90 degrees, right? The same exact rectangle that you have seen on the other side. So far we have this angle right here. So I'm interested in finding out how much this angle is, because that angle corresponds to this part of the circle. I want to know how much of the circumference of the circle is that particular arch, right? That particular just arc length there. So that curvy part right there. I want to know how much of a circle of the circumference is it, right? So if I know that angle right there, then I could find out. So let's call that angle x. Okay, so you can see that x plus 90 plus 90 plus 60 has to be a full rotation, which is 360 degrees. So x plus 90, 90, 180, 240 is equal to 360. So x must be 360 minus 240, which is 120 degrees. So x right here is 120 degrees. So what's the relationship? 120 degrees out of the full rotation of 360 degrees. If you reduce that, that is 1/3. So this length right here, this length right here, that is in yellow, that length right there is 1/3 of a circle, and you have 3/3 of a circle. So then the rounded part makes a full entire circumference of a circle, right? So now your rope, okay, so let's go ahead and make it smaller. Okay, so your rope would be 20 plus 20 plus 20 plus 3/3 of a circle, and 3/3 of a circle is a full circumference, right? That would be the circumference. And how do we find the circumference of a circle? Pi times the diameter, which in this case is pi times 20. So the rope is 60 plus 20 pi long. And you can use your calculator and get an approximation for that as your answer. And that is it, right? So sometimes what you would have to do is sometimes you would have to really draw in extra lines to help you see things better. And the helpful hint right there was that the radius is perpendicular to the tangent line at the point of tangency. Now you wouldn't be expected to know that, and that's why that hint is there for you. So you should, when you're doing geometry, if extra lines are needed, draw them in so that you can see better. Okay?